All right, now let's revisit that last problem one more time. So in that last problem, we are trying to find numbers a and b that would make 5x minus 3 over x plus 1 times x minus 3 equal to a over x plus 1 plus b over x minus 3. So what we did in this problem is we said, okay, well, it'd help to get rid of fractions. So what we did is we multiplied both sides by x plus 1 and x minus 3. We canceled. And we ended up with this system of equations here. We ended up with this equation to solve for a and b. 5x minus 3 equals x minus 3 times a plus x plus 1 times b. Now it turns out there's a shortcut for solving this equation, solving this equation for a and b. Really fast method. So we're going to do that here. Let's figure out what a and b are. If 5x minus 3 equals x minus 3 times a plus x plus 1 times b. All right, so this trick is called the Heaviside method, after Oliver Heaviside. It turns out Oliver Heaviside didn't actually discover this. That's an interesting story. You should ask me about that sometime. Anyway, so the idea is this. This equation must work no matter what x is. This equation is supposed to be true for any number that you plug in for x. You have this line equaling what'll be this other line. And so if one line is equal to another, that's got to be true for all x values that you plug into the two lines. You're supposed to get the same y value always. Well, if this is supposed to be equal to this for all x values, it certainly needs to be true when x equals 3. So let's plug in 3 for x on the left side of the equation and 3 for x on the right side of the equation. On the left side, you get 5 times 3 minus 3. On the right side, you get 3 minus 3 times a plus 3 plus 1 times b. So on the left side, you get 15 minus 3 is 12. And on the right side, you get 0 times a. Well, that's just 0. And then you get 4 times b. So that's 4b. Aha! 12 divided by 4 now is 3. b must be 3. So we have our b value here. All right, well, let's say that we wanted the a value now. Well, look at this original equation. So we plugged in 3 for x. Well, let's plug in -1 for x now. So we can say, well, what happens when x equals -1? So I'll plug in -1 into the left side of the equation and into the right side of the equation. I'll have 5 times -1 minus 3 equals -1 minus 3 times a plus -1 plus 1 times b. -5 minus 3 is -8. -1 minus 3 is -4. -1 plus 1 is 0. 0 times b is 0. So left with the equation -4a equals -8. Divide both sides by -4, and you get that a equals 2. So here's a nice fast method for finding your a and b. Now you might be wondering, well, why didn't we just do this in the first place? Well, this is great when it works, but this doesn't work as well in more complicated examples. So the first method I taught you of solving a system of equations will work no matter how complicated the example becomes. This method works great on nice simple examples.